Hi, myself Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today I will to tell about the fabrication of nanomaterials combustion method. So, introduction. In this combustion synthesis method, it consists of bringing a saturated aqueous solution of desired metal salts and suitable organic fuel to boil until the mixture ignites and rather faster combustion reaction takes off, resulting in a dry, usually crystalline and fine particle oxide powder. So here it involves in this method. It involves it consists of bringing a saturated aqueous solution. So saturated aqueous solution means that the solute which is dissolved. The solute which is dissolved in water. The solute which is dissolved in water is the aqueous solution. So, this method consists of bringing a saturated aqueous solution. So, aqueous solution means that the solute which dissolves in water called as aqueous solution. Suppose for aqueous solution, if we take an example, NaCl, so sodium chloride, it is a solute. Sodium chloride. It is a solute. When this sodium chloride is mixed with water, so water acts as a solvent. So when sodium chloride solute is mixed with water, so it dissolves. Sodium chloride dissolves in water. So it is an aqueous solution. So aqueous solution is a solution of homogeneous mixture of solute and solvent, that is a solute dissolved in water. So this method consists of bringing a saturated aqueous solution of the desired metal salts and a suitable organic fuel. So organic fuel in the sense it may be biofuel or it may be biodiesel or green diesel. So like that we can add some organic fuels. So these organic fuels means that these fuels, that is biofuel, includes ethanol. So it is derived from corn in USA and from the sugar cane in the Brazil. So this biofuel is derived from the sugar cane or else from the corn. So biodiesel. So biodiesel can be get from the vegetable oil and liquid animal fats. So green diesel also derived from the algae and other plant sources. So like that, biogas. From that biogas we can get the methane. So it comes from the animal manure and other organic digestive materials. So here the solution is mixed up with suitable organic fuel. Then let it be bring it to boil. It will bring it to boil until the mixture ignites. So at a particular ignition temperature, the solution will be burned. So until the mixture ignites and rather faster combustion reaction takes off, after that it will be dry and we can get a crystalline and a fine particle oxide powder. So combustion synthesis method consists of bringing a saturated aqueous solution of the desired metal salts and a suitable organic fuel to boil until the mixture ignites and rather faster combustion reaction takes off, resulting in a dry, usually crystalline and fine powder oxide powders can be obtained from here. And so A combustion synthesis is characterized by highly exothermic reaction. So exothermic reactions is exothermic means that which releases lots of heat. So a reaction which releases lots of heat. So combustion synthesis is characterized by highly exothermic reactions with the temperature ranging typically from 500 to 1000 degree centigrade. So these kind of high temperature reaction can combine metals and non-metals to produce a wide variety of advanced materials like ceramics, ceramics, intermetallics, solid solutions, and metal matrix composites. So this is the diagram which gives about the combustion method. So here first we are mixing the components, then the foam will be formed, then combustion takes place, then finally we are getting the product. So first we are taking the solution. So mixing up the components, that is we are taking aqueous solution, then we are adding some metal nitrates and then adding some organic fuel. So that we are having some mixing of components, then we are making it to dry. So some foam formation will be happens. So when heating this solution, flames will be come out at some particular ignition temperature. So that means combustion starts. So after that combustion, what happens after cooling? So there will be some fine powder of particles which gives the nanoparticles. So this is the final product which gives the nanoparticles. So combustion method of synthesis is effective method for synthesis of nano-size materials, and it has been used for the production of variety of more than 1000. So it is a traditional method. And for example, zinc oxide, copper oxide nanoparticles can be synthesized by using this combustion method. So principle of solution combustion method. So solution combustion is an exciting phenomena which involves propagation of self-sustained exothermic reactions along an aqueous solution. So self-sustained. So in this phenomena, it involves propagation of self-sustained exothermic reactions along an aqueous media. So we are taking an aqueous solutions and adding some biofuels and then so we are taking some aqueous solutions. So we are taking aqueous solution so that we are adding so fuel and then some metal precursors, so that when heating this solution, some self-sustained exothermic reactions takes place in this aqueous media. So this process allows for the synthesis of a variety of nanoscale materials including oxides, metals, alloys and then sulfides. So this technique is used widely to obtain metal oxide and insulator materials. This technique is widely used to obtain metal oxide and insulator materials. So in this technique, first we should make a solution and then heat the solution. So when heating this solution, it will start burning. The solution will be burned. So when it starts burning, flames will be come out from that one and it evaporates some gases. So after cooling this solution, we'll get a remaining product, that is that remaining ash will give us required nanomaterials. So in this technique, first we should make a solution. So that solution is with solute and solvent. So we should make a solution with solute and solvents. So sometimes making this solution may require stirring provision. That is, we have to stir up with magnetic stirrer. We have to stir up with the magnetic stirrer or magnetic pellet. By using magnetic pellet, we mix up this solution. Then the solution is heated, and once the solution is reached auto ignition temperature, it starts burning by indicate through the flames, by indication of flames. So with evaporation of some gases. After completion of burning process, the remaining ash will give us the required nanomaterials. So here there is a metal precursor which is added a fuel, water, the additives. So here there is a solution, aqueous solution with metal oxides. So there is a metal precursors. So this solution is brings to heat. So at 80 degrees centigrade, the solution will be in the gel form. After that, increasing the temperature at 250 degrees centigrade, the gel starts burning. So at this auto ignition temperature, it gives flames. So after that combustion, that is after that burning process, let it be cool, and then we can get a fine powder of nanoparticles. So that is, after burning, the remaining product gives the nanoparticles. Which is required. So mesoporous metal oxide nanoparticles can be obtained finally. So that is outstanding nanoparticle catalysts. So with the 5 structures. So combustion reactions always involves a molecular oxygen, O2. Anytime anything burns, it is a combustion reaction. Combustion reaction are almost exothermic. So exothermic means they gives off heat. In a combination reaction, the atoms or molecules combine to form or to combinedly gives the new product. So in the combustion reaction, if we take an example, when wood burns, it does in the presence of oxygen. If wood burns in the presence of oxygen, and it releases a lot of heat. So when wood burns, it must do so in the presence of oxygen, and a lot of heat is produced. So wood plus O2 will give ash and heat. So wood as well as many common items that combust are organic. So going for the second example, when organic molecules combust, the reaction products are carbon dioxide and water as well as heat. So here organic molecules with the carbon, hydrogen and phosphorus with the presence of oxygen, so we'll get a carbon dioxide and then water, and some heat will be produced from this reaction, combust reaction. So let's go through into the procedure of this combustion method. So first we are taking an oxidizer. In the oxidizer is dissolved into the distilled water by mixing with magnetic stirrer. So after that the solution, this is the solution. So for this solution we add a fuel, organic fuel, and stir it again. So by using this magnetic stirrer, this is a magnetic stirrer. This is a magnetic stirrer. So in this magnetic stirrer, we are taking the solution with the adding of fuel also. So when it is stirring with the magnetic pellet through the magnetic stirrer, the solution will be mixed up fine. So in this solution, we kept some magnetic pellet, and keep it in the magnetic stirrer. So by keeping some rotations, the pellet will be rotated inside the container, so that the solution will be mixed up very well. So after stirring, it will be bring to keep it on electrical heater. So heat the solution with the electrical heater. So during the heating, smoldering, flaming and fumes will take place. Here we can see the fumes. So after cool the temperature, that is cool the container, and we can finally get a new product in the container in the form of powder, then like a ash-like powder. Then this material is sent to calcination. So in this method, we have some advantages, that is 20 to 50 nanometer size nanoparticles can be synthesis, and less time is required to do it. No inert gas is required, no need of vacuum, and it is a less cost. So when coming to the applications, zinc oxide nanoparticles are used in the food packaging, as zinc oxide nanoparticles have antibacterial properties. So is also influenced by their concentration and particle size. In many studies, it has been seen that antibacterial activity increased with the increase in the surface area and concentration. Metal oxide nanoparticles have a higher surface area due to their smaller size, which makes them useful in various applications such as biosensors, bio-nanotechnology, and nanomedicine. These nanoparticles have many atoms on their surfaces, making them highly reactive. Different features of these nanoparticles are attributed to their crystallinity, size, content, and shape. So they can easily enter the inner structure of the cells and interact with the cell biomolecules. So this is all about the combustion method. So in this combustion method, we are taking aqueous solutions with some metal salts and adding with the fuel, and then bring it to boil with some electrical heater, so that when it is heating up at some ignition temperature, what happens at the ignition temperature, the solution starts burning. So by the indication of flames, we can see that a combustion reaction is starting. So after cooling this container, we'll get a fine powder like ashes that will gives the mesoporous nanoparticles, metal nanoparticles. That is, we'll get the nanoparticles from that remaining solution. So like that, we can synthesize the nanoparticles by this combustion reaction. So the references for this the topic, Engineering Physics by K. Tyagarajan, Tata McGraw Education Private Limited, New Delhi. Textbook of Engineering Physics, M.N. Avadhanulu, P.G. Kshiresagar, S. Chand and Company, New Delhi. Engineering Physics by Dr. M. Armuga, Anuradha Publications, Chennai, 6,70,000. Engineering Physics by P.K. Palanisamy, 4th edition, Zytec Publications, Private Limited, Chennai, 6,70,000. So these are the references which belongs to the combustion method of synthesis. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.